Okay, so this is going to be kind of a makeup demonstration, something that I would have shown you during the Data Umbrella talk had the network allowed it. So this is the IRSA homepage, and right on the top there's a place to search by name or coordinates just to see what IRSA has available. You can certainly do that, but it might not be the best place to start because I think it can be pretty overwhelming. The rest of the page, here's this row of red icons, which we're going to come back to again and again. This is a catalog search too. This is the generic image and catalog tool. This is Finder Chart, and this is the instructions on how to interact with the archive using APIs, basically Python. And then down here, there's a whole bunch of mission-specific pages. If you go down further, there's video tutorials. So that's where you want to go to get pointers to the YouTube feed and specific tutorials and little short videos on specific aspects of this. But to start with, let's go to Finder Chart, which is this one right here. Let's click on that. Now I talked about this a little bit with the slide, so hopefully it's still intelligible. Here you have to put in initially a position. You can put in a position on the sky or a name. I'm going to use M16, which is the Eagle Nebula. And you see it turned that name into coordinates right here for me. Then it's image size. You have to pick your units first and then change the number. Then depending on whether you're on a small, tiny laptop or a big monitor, you might want to change that. Here are all of the catalogs, and I did mention this on the slide, so hopefully some of that came through. But just to review, these two are optical. This is the DSS, which is the digitized sky survey. It is a digital version of the Palomar Observatory sky survey, which was photographic plates from the 1950s. And this is the Sloan Digital Sky Survey. It is a ground-based telescope, and so it can't see the whole sky, and it didn't survey the whole sky even that it could see, but it surveyed a lot of it. So there's optical data there too. 2MASS is an all-sky ground-based survey. That's in the near-infrared. WISE is a space-based near and mid-infrared all-sky survey. Spitzer was not an all-sky survey. It was a pointed observatory, but most of the famous things are observed. And the specific data product you're looking at is something called SEIP, the Spitzer Enhanced Imaging Products. Akari was a Japanese mission, and the data that we've got here available through this tool are far infrared. And then IRAS was the first all-sky infrared survey from the 80s. I mentioned that during the talk too. I recommend that when you're just starting out, you turn off the searching the corresponding catalog because it'll be pretty overwhelming, and I'll show you why eventually. But let's turn it off just for now and then click search. So it's going to go grab the same patch of sky for, from each of these surveys. So here, remember, this is digitized sky survey. So this is digitization of photographic plates from the 1950s. This is from the mid-80s, and this is from early 80s. But they're all photographic plates. Near-infrared 2MASS, near and mid-infrared WISE, mid-infrared Spitzer, far-infrared Akari, and IRAS. You can see the pixels for IRAS are huge because you have to remember this was the first all-sky infrared survey. So, technology was a lot different then. So the pixels seem enormous, and even for Akari, the pixels seem pretty big. But you see here, they're all reverse grayscale. And I mentioned that astronomers tend to like reverse grayscale. Here's the pull down from which you can choose a different color table. Now, one of the reasons I put off recording this initially was because I was hoping we would have a brand new release. This tool didn't get released today, so by the time you get to it, this interface might look a little bit different, but you can still pick any other color table that you want, and it will change the color table in each of the images to be whatever you've picked it to be. Here's how you change the color stretch. You go color stretch. See, it's giving you a histogram of the values in the image that you selected. See, this is outlined in orange. That's what the histogram is. If I pick a different image, you can see the histogram is very different. So it's coloring the histogram with the colors that is used in the image. So if you want to, we talked about linear stretches, you can also pick a logarithmic stretch. Histogram equalization is one of those things where it's trying to distribute the colors over the places where there are values in the histogram. So that's often used a lot in these kinds of applications. You can choose the stretch to be by percentage or data value or scatter in the data, and then refresh the images, and it will update the images to be what you picked. You can also, let's do this and go all the way back to the beginning and reset everything. Here, this button right here is a 3-color button. So if you click on that, it adds a 3-color image to the end of each row. So this 3-color image has picked 3 bands from this row to make a 3-color image. In this row, there's only 3 bands, so it's used all 3 bands. Here it's picked 3, here it's picked 3, and in those 2, it's also picked 3. So you can see it's trying to make a color image. Here, though, you can really see these dramatic fingers or the talons of the eagle that become much more prominent at longer wavelengths. They really show up as red in the 3-color image. You can also measure distances. So let's click on the ruler, and then you can click and drag in the image. And then if you go to the layers icon, you can say, I'd really like to see that measurement in arc minutes. So 1.87 arc minutes or 112 arc seconds is how long that is in terms of angle subtended on the sky. If you want to see how big that really is, you'll have to do a little bit of research and find out how far away the Eagle Nebula is. It's M16. Once you figure out the real distance to the Eagle Nebula, and given this angular distance and a little bit of trigonometry, you can figure out how big that is in kilometers. Okay, let's show you why you don't want to start with the catalogs. Rather than going back to there, let me go back to the front page and go to IRSA, to the Finder chart, and then I'm going to put in M16 again. I'm going to leave all of those the defaults. I'm going to turn off Akari and IRAS. I'm going to turn off Sloan because there's no data from Sloan here. This time I'm going to say yes, search the corresponding catalog. I'm going to ask it to search within the image boundary. So it's pulled the same chunk of sky, and now it's pulled catalogs for each one of these. So for the Palomar Observatory Sky Survey, there's no catalog that goes with it. So there's no catalog overlaid. Here you've got the 2-mass catalog overlaid on the 2-mass image. You've got the WISE catalog overlaid on the WISE image. Here you've got the Spitzer catalog overlaid on the Spitzer image. So you can see how pretty overwhelming that can be pretty quickly, because if you ask for a larger chunk of sky than I did, you can pretty clearly get to the point where you only see the overlays. You only see green or you only see red, because there's just so many sources that you can't really see the image underneath. It's made a plot of the image over here on the right, and here's the catalog on the left. So you can interact with these things. Let's turn on filters. Now, this is the brightness in these funny units. This is WISE 1 signal to noise ratio. In other words, how high quality that measurement is. So for signal to noise ratios, big is good. So if I filter that down to greater than 10 and greater than 10, whoops, that's not right. Greater than 10. So now I have fewer sources that appear on the image here, fewer sources in the plot, and they're all interlinked. So if I want to know, hey, what's the measurement of that source? Click on it in the image, it's highlighted in the catalog, and it's highlighted in the plot. I can change what's plotted to. This is another thing that's hopefully going to change in the next couple days. I'll show you what the new one's going to look like in another tool in a minute. But I can change what's plotted. I can use these funny units. So W1M Pro minus W4M Pro. I know it says minus. It's actually a flux ratio between 3.5 and 22 microns. That's a whole separate discussion. W1M Pro. And then like I was describing, we need to reverse the y-axis because we need large numbers to be at the bottom, because large numbers means faint in these funny units astronomers use. Okay, so close. Here we've got brightness and color. If I pick that, it's something that's really red, and it's this source that's highlighted in the image and that source that's highlighted in the table. So let's go back and look at IRSA Viewer. So IRSA Viewer is the more generic version, right? So you can see it has the same look and feel. So I put in M16 again, and for this, let's do a degree. Let's see if we can get a big image of the Eagle Nebula. Now down here at the bottom, there is truly a dizzying array of data sets to choose from. You can filter down this list by using the filters on the left. So I happen to know that M16 was observed by Spitzer and will appear in those imaging products. Let's say I want to pick from WISE too. If I click on WISE, then I only have the 3 data sets that are WISE related. I'm going to pick all WISE, and I'm going to pick Herschel, which is far infrared. and I'm going to pick 2 mass. So 2 mass, because it dates from the early 90s, the individual image tiles that are stored are relatively small because the computers and the internet weren't very fast then. So if you want a relatively big chunk of sky, you want to choose the 6-degree mosaics, not the 6x, but the 6-degree mosaics. Search. So now it's going to go try and pull the same chunk of sky from all of these surveys. So sometimes it's not going to find anything, in which case it's going to tell you. And in order to make that go away, you click on the X, and it'll make that image go away. I mentioned in the talk that sometimes FITS images can have many planes. Here's an example of many planes in the same file. You can scroll through the planes. Now, find your chart, because of the nature of the beast, it knew that every image it was displaying was the same chunk of sky. With IRSA Viewer, it can't assume that. So by default, it hasn't aligned all the images. If I pick this one and make it as big as possible, see how it's outlined in orange? I'm going to go over here and do align and lock by WCS. Then all of the images are going to align and lock together. So that if I grab and drag this one, all of them move. Right? If I zoom in, all of them zoom in. And they're already locked by color tables. So here's the new interface to the color tables. You can pick a different color table that way. You can also change the bias and the contrast. You can also change the color stretch, just like I showed you in the other tool. So there's lots of things you can do. You can also get a list of the images and sort them by wavelength by clicking on that. And now all of these are sorted by wavelength. So you have the shortest wavelength at J, which is like 1 micron, and Spire, which is like 500 microns. So same chunk of sky, but many different wavelengths. Here too, you can get catalogs. So let me go over here. Here, I can get catalogs from IRSA or from other archives at IPAC. I can load a catalog from disk or from the web. This allows me to interact with various archives all over the world that have virtual observatory capabilities. So, and then this is a particular protocol within the virtual observatory. This is another virtual observatory kinds of search. So if we go back over here to IRSA, this time I'm going to ask for a polygon over the whole image and then search. So just like in the other tool, it's going to load in the catalog and make a plot. But it may take a couple seconds because I just asked it for a fairly large chunk of sky. Okay, I'm going to send this to the background while that's still thinking. Here you've got all the same tools. You can measure distances, you can put a coordinate grid on the images. To turn it off, just click on it again. Let's see. Oh, it says it's ready. Show the results. Okay, so now it's got a table down here and a plot up here, and you see it's overlaid the sources on the images. And there's so many sources you no longer see images. So let's do one image at a time and zoom in relatively far. Now over here, there's so many points because we've got almost 23,000 points loaded in. It doesn't actually plot individual points anymore. It's just giving me like density. This is like a heat map of how many points are in each one of these cells. So let's filter down this catalog. Let's say W1 SNR greater than 10. Remember, signal to noise ratio, big is good. So we're going to require that this be greater than 10 in all 4 of the wise bands. And now you have only 1,700 sources left, and you can see the individual sources here. So here's the new interface. So you see it's a little different than the other one, and there's different choices you can make. So you can, for example, tell it, I would like you to make them purple rather than blue points, apply. Or you can say, I would like to make the color map scale with a particular value in the catalog. So let's do W1 SNR and say, let's make the color corresponding to those values run from yellow to green to blue. Apply. And now it's changed the colors so that the colors now scale with the value of W1 SNR. You can also change the size map. So if I change that W4 SNR You can change the, come on, apply. You can change the sizes of the plots as well. And they're still interactive. You can still click on them and, you know, get taken to that source in the catalog and in the image. You can see the image is struggling to load, but it's jumped to the location of that source. Let's go back to the main homepage and just wrap up with a few thoughts. SOFIA, that's the plane from NASA that has a telescope inside and a hole in the side that looks out. You can put in a source and see what's available. This is, however, pretty complicated data, so I would be leery of jumping into this to start with. There's some imaging, lots of spectroscopy. So I typed in M42, which is Orion. All of these polygons are individual observations that it found looking at M42, which is the Orion Nebula. You can also search on, let's do this. Let's do real quick. WISE, and we want to do a time series. So multi-epoch, meaning individual observations over time. I'm going to put in RR Lyra, which is a known pulsating star. And then, come on. Okay, so it's come back with 49 epochs. Now, the original default plot looks very silly because all the points are in the same spot on the sky. If you click on to time series tool and then click on the source ID, it will load those observations into the time series tool. So you see here we have brightness measured as a function of time here, and the individual epochs are on the bottom here. And then if I click on period finder, it's going to do that math magic that I mentioned, where it's going to look for repeated patterns in the data. If you want to look it up, it's a Fourier transform, specifically Loam-Scargill, and you want the peak value. And if I accept that over here, this is the original brightness as a function of time. But this right here is brightness as a function of phase, in other words, part of the cycle. So the specific period that is best for this star is about 0.56 days. So every 0.56 days, it pulsates and gets brighter and fainter and brighter and fainter. And so this is lining it up so that the same part of that cycle appears in the same phase here. And yes, it's copied it twice so that you can see the whole pattern that gets traced out. So those, I think, were all of the things that I was hoping to be able to show you the other day. Let me just remind you again that there is a collection of video tutorials here. They're organized in playlists by tool, but then almost all of these are very, very short, so you can watch them. They all have closed captioning, so you can rewind me, slow me down, read the closed captioning rather than trying to listen to what I'm saying as you're going along and trying to reproduce the examples given in the videos.